بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. اولا عام سعيد عليكم ان شاء الله. النهارده اول يوم في رمضان، الموافق 24/4/2020. لقيت ان انا مهم اوي ان اتكلم على الجزء الخاص بايونيك ايكوليبريم. في ناس كتير طلبت مني المراجعة بالنسبة للجزء ده، فهنبدأ النهارده ان شاء الله. Today ان شاء الله we are going to talk ionic equilibrium. Before talking about the ionic equilibrium, we are going to talk about the type of solutions. Types. When having a two type of the solutions may be electrolytic and non-electrolytic. Non-electrolytic can't conduct electricity since no ion produces from it. Okay, that's for the moment. And when we talk about the electrolytic solutions, we have the two type of electrolytic solution. We have a strong and a weak. The strong, it's completely ionized as an example, HCl. When dissolve it in the water, it giving to us in the one direction only, since it's completely ionized, gives ions. Completely ionized gives positive and the negative ions. So it's giving to us H3O positive hydronium ion plus chlorine. When we talk about the weak, it's incomplete ionized. Gives small percentage of ions in aqueous solution. Let's take an example, CH3 COOH. It is a liquid. When it dissolves in the water, it's giving to us else liquid. It's giving to us, since it's the weak, forward and backward, it's giving to us acetate plus hydronium, aqueous and aqueous. Okay, now we are going to make an experiment to detecting what is the difference between electrolytic and non-electrolytic. The experiment. Firstly, design cell as in following figure. Then add solutions and record observations. Our cell, it will be like this. Container contain two different pools, maybe from graphite when having a key, lamp, battery, then we add the solutions. What is the solution that we add in this cell? Number 1, HCl, hydrochloric acid, and benzene. Number 2, acetic acid, CH3COH, and benzene. Number 3, HCl to water, 0.1 molar concentration. Number 4, CH3COH to water, 0.1 molar concentrations. Dilute. Dilution. 4. Solution number 3, HCl to be 0.01 molar concentrations. Number 6, dilution for solution number 4, CH3COH to be 0.01 molar. Our observations. The first case, no elimination, for lamp after close the key, and else the same observations in the case of acetic acid and the benzene. Why none? Because both of them non-electrolytic solution, no ions produce, no ions produces. When we adding HCl to the water to be 1 molar concentration, a strong elimination for the lamp, since HCl are strong electrolyte, completely ionized. For acetic acid in the water, weak elimination since it's partially ionized. For lamp, since small percentage of ions produced. After the dilution for hydrochloric acid to be 0.1 molar, no change in lamp elimination, since it is strong electrolyte. After the dilutions for acetic acid to be 0.1 molar concentrations, elimination strength increase, due to dissociation of new ions from acetic acid. في الحالة دي يا شباب we'll find that a percentage from the acetic acid and new ions are dissociated. يعني في معناه ان في ions جديدة هتنتج لما يتفكك الاسيتيك acid موجود في المية، ولكن لما نعمل dilution more ions will be dissociated. في ions جديدة هتبدأ تتفكك مع جزيئات المية الجديدة اللي ظهرت، فبالتالي يحصل ايه؟ increasing elimination of the lamp. But the elimination of the lamp in the case of dilution for the acetic acid, it will not be like the HCl, since HCl is strong electrolyte. Okay, now we are going to talk about the concept that can be obtained from this experiment. Okay, concept obtained from the previous experiment. The first step will be ionization. Ionization, it means the process of changing molecules to ions. Number 2, complete ionization. Process take place in a strong electrolyte when all molecules changes to ions. Incomplete or incomplete ionization. Incomplete ionization. Process takes place in weak electrolyte when a small percentage of molecules change to ions. Ionic equilibrium. Ionic equilibrium, it means equilibrium state takes place between molecules and ions in weak electrolyte. Hydronium. Ion. Hydronium ion, H3O positive. Positive ion produces due to combination between positive hydrogen ion and water molecule by coordinate bond. Okay, from this we'll find the important give reasons that taking place in the ionic equilibrium and this concept. Okay, let's go to see this concept or this give reason. Okay, give reason 4. Number one from these give reasons in the exams, inshallah. The elimination of lamp are very strong when we add HCl to water. Number two, the weak elimination of lamp when we add acetic acid to water. Number three, law of mass action applied in weak electrolyte. Number four, law of mass action not applied on a strong electrolyte. Number five, in exam of 2019, no free hydrogen in the aqueous solutions. Let's answer. This is slide number 4. Number 1, the elimination of the lamp very strong when we add hydrochloric acid to the water, because hydrochloric acid or HCl are strong electrolyte, completely ionized, in water, gives positive hydrogen or positive hydronium and negative chlorine. Weak eliminations due to dissociation of a small percentage of acetic acid molecule to ions. Number 3, law of mass action are applied in the weak electrolyte because it is incomplete ionized in aqueous solutions. But law of mass action are not applied in strong electrolyte because it is completely ionized in aqueous solution. No free hydrogen in the aqueous solution because the positive proton attach to water molecule through hydrogen bond, or the coordinate bond. Let's explain it. When I have the free hydrogen ion, this free hydrogen ion has empty orbital, there is no electron in it. And we'll find the water molecule. Water molecules have two lone pair of electrons. By one lone pair of this pairs are making the bond with this proton, so it giving to us O coordinate bond with this proton, and H and H. Still only one lone pair of protons from oxygen, and the positive charge it take all the compound forming the hydronium. This bond can called coordinate bond. Coordinate bond in the secondary, that when have a donor atom by a lone pair of electrons and acceptor atom for a lone pair of electrons. Okay, let's go to a compare about this part that may be taken or found in exams. Okay, important comparison. Or important compare. Number 1, compare between proton and the hydronium ion. Number 2, compare between strong and weak electrolyte. Number 3, compare between complete and incomplete ionization. Number 4, compare between chemical and ionic equilibrium. Okay, firstly, we'll start by the proton and the hydronium. Proton, hydronium. For the protons, it is the positive ion, positive hydrogen ion, has no electrons in its orbital. For the hydronium, positive proton or positive ion produces due to bond between positive hydrogen ion and water molecule by coordinate bond. Okay, this is the first comparison. The second one, number 1, complete and incomplete ionization, or strong and weak electrolyte. Strong electrolyte, weak electrolyte. For the strong electrolyte, conduct electricity, by huge degree huge or large degree as it completely ionized in aqueous solution. An example: HCl plus water, it giving to us only in one direction, hydronium ion aqueous plus Cl negative aqueous. Weak electrolyte conduct electricity by low degree as it incomplete ionized in aqueous solution. We can replace word incomplete ionized by small percentage are ionized from its molecule in the aqueous solution. An example: CH3COH, acetic acid, is a liquid. When it attaching to the water molecules as a liquid else, you will find it's the weak electrolyte. The reaction go forward and backward. It giving to us acetate negative aqueous plus hydronium aqueous else. Still, to compare between strong and weak electrolyte, chemical and ionic equilibrium, to slide number 5. Okay, compare number 3, strong or the complete and incomplete ionization. Incomplete ionization, complete ionization takes place in strong electrolyte when all molecules changes to ions. And the previous examples of the HCl, when it in the water molecule, giving to us hydronium plus Cl negative, liquid, aqueous, and aqueous. Incomplete ionization take place in weak electrolyte when small percentage of molecules changes to ions. As an example, the acetic acid as a liquid plus the water, liquid else, will find the forward and backward, giving to us acetate aqueous plus hydronium. The last comparison they ask about it in the exam: chemical and ionic equilibrium. Chemical equilibrium, ionic equilibrium. For the chemical equilibrium, change the pen. Equilibrium takes place in reversible reaction when the rate of the forward reaction equal the rate of backward reaction, and both of reactant and product are in medium of reaction. As the reaction between acetic acid CH3 COOH liquid plus ethanol C2H5 OH liquid else, we will find the forward and backward, giving to us during the reaction between alcohol and the acid, the alcohol shared by H while the acid shared by OH to forming the water, and CH3 COO C2H5 ethyl acetate or ethyl ethanoate. Since these reactions take forward direction and backward, we will find both of the reactant and the product in the medium of the reactions. But for the ionic equilibrium, it is equilibrium state in weak electrolyte between the molecules and ions reduces from it. An example, the acetic acid liquid plus the water is liquid, giving to us forward and backward, giving to us the acetate ions plus the hydronium ions. Okay, for correction of our informations, when I write the equation of HCl in the water, the physical state, the HCl are the gas, since it is the gas dissolved in the water, liquid, giving to us H3O hydronium at the aqueous plus chlorine at the aqueous cells. Okay, when we're talking about Ostwald law, before talking about the Ostwald law, we'll find the four important right scientific terms that in the exam, one of them are in the exam. Number one, right scientific term, the relationship between degree of ionization and the concentration of weak electrolyte. Number 2, find the relationship between degree of ionization and concentration of weak electrolyte. Number 3, the relationship between rate of the chemical reaction rate or speed of the chemical reaction and concentration of reactants. Number 4, find the relationship between speed of the chemical reaction and concentration of reactants. The answer. The first one, the relationship between the degree of ionization and the concentration of the weak electrolyte is called Ostwald law. The founder, or he find the relationship between the degree of ionization and concentration, Ostwald. The relationship between the speed of the chemical reaction and the concentration of the reaction, it is law of mass action. Founder, or find the relationship between the speed of the chemical reaction and concentration of the reactant, Goldenberg and Vag. Okay, one from this right scientific term may be defined, or the right scientific term we will find maybe in the exam, inshallah. Okay, next we are going to talk about the mathematical detection for the Ostwald law. Maybe at this point it's not important, it's not come before in the general secondary certificate before, but it's very important from the other secondary stages, or the third secondary and other. Okay, so at all we must take in consideration this one from the very important detection. Okay. Okay, take care the student of Al-Azhar, detect Ostwald law. We'll take the line. In this line we'll write equation of the dissociation of monoprotic weak acid. Moles before distillation. At start of distillation. Number 2, degree of distillation moles after dissociation. Concentration, constant of dissociation, Ka, dissociation constant. Firstly, we said that is a weak electrolyte. Ostfeld does work on the weak electrolyte. So let's start by the weak electrolyte, monoprotic weak electrolyte. Weak electrolyte, that means that the reaction goes forward and backward. It giving to us H positive plus A negative. Number of moles at the start of the reaction, it will be 1, 0, 0. There is no concentrations for the ions. Degree of dissociations, we'll find this, it decreases by alpha, and this is increases by alpha. The moles after dissociation, it will be 1 subtract alpha, it will be alpha and alpha. The concentrations, concentration equal number of moles over the volume. So the number of moles 1 or subtract alpha divided V. This is alpha over V, and this alpha over V. Dissociation constant, or Ka, it's equal the concentration of the product over the concentration of the reactant. Ka equal concentration of product alpha over V multiply alpha over V, 1 subtract alpha over V. So it will be alpha square over V square, 1 subtract alpha V. The V is neglected. With the square, it will be alpha square. So Ka equal alpha square over V divided 1 subtract alpha equal alpha square multiply 1 over V over 1 subtract alpha. Since it is weak electrolyte, degree of dissociation very small, so 1 subtract alpha nearly equal 1. So it will be Ka equal alpha square multiply 1 over V. 1 over V, 1 represents the number of moles. 1 over V, number of moles over the volume giving to us concentration. So the final detection or mathematical relationship for Ostfeld law, it will be Ka equal alpha square C, Ca, dissociation constant, degree of ionization, concentration of weak acid. This is Ostfeld mathematical relation. Okay, we have else two detection. Alhamdulillah. Still two detection is very important else for the Azhar. So take care, and it's very important for the general secondary certificate for the problems. Okay. Two detections for the as applications on Ostfeld law. Applications on Ostfeld law. Number 1, detect that Ka or hydronium ion concentration equal root Ka multiply Ca, or detect mathematically the concentration of hydronium ion produces from weak distillations or distillation of acetic acid. In water. Since we said that is a weak electrolyte, so firstly I must write the equation. Acetic acid liquid adding to the water liquid else. Direction goes forward and backward. It giving to us acetate aqueous plus hydronium positive aqueous. The equilibrium constant or distillation constant Ka, it's equal the concentrations of the product hydronium and acetate divided the concentration of the reactant, but we neglected in calculating the distillation constant, as we said before, we neglect the liquid water, BBT, and the salt substance, so it giving to us acetate. Acetate is a liquid else, mister. No, I am said liquid water, not any other liquid. Since it is a weak electrolyte, so the concentration of the hydronium equal the concentration of the acetate. So we can replacing the acetate by the hydronium. So at Ka now, in this case it will be hydronium multiply the hydronium over the acetate. So it will be Ka equal hydronium ion square over acetate. We can replacing the acetate by the concentration of the acid. So hydronium ion concentration square equal Ka, and replace CH3COH is by the concentration of the acid Ca. The final results will find hydronium ion concentration equal root Sacca, concentration of the acid, equilibrium distillation of for the acid. The second relationship as an applications on Ostwald law. The detections for the concentration of the hydroxyl ion detect just the slides. I'm saying this is slide number 9. Detect mathematically that OH negative equal root sap cap, concentration of the base, distillation constant for the base, or detect mathematically the concentration of hydroxyl ion, negative hydroxyl ion, produce from dissolving ammonia gas in water. Okay, ammonia NH3, it is the gas that dissolve in the liquid water, it giving to us forward and backward, giving to us ammonium aqueous plus OH negative. The Kb, it's equal the concentrations of the product over the concentration of the reactant. Neglect the liquid water since it's the constant concentrations, so in H3. Then, since it is weak electrolyte, so concentration of the ammonium in H4 positive equal the concentration of the negative hydroxyl. So we can replace the ammonium by hydroxide. So Kb equal OH negative multiply OH negative divided in H3. So OH square OH negative square over NH3. NH3 related to the base concentration, so it may be equals Cb. So Kb equal hydroxyl ion concentration square multiply our divided Cb. So hydroxyl ion concentration power 2 or the square equal Kb multiply Cb. It will be hydroxyl ion concentration root sep cap concentration of the base times the dissociation constant for the base. Okay, now we are going to talk about the water ionization. Water ionization in the May 2005 General Secondary Certificates. Write this question. Write the ionization equation of water and what is the type of equilibrium. Okay, the dissociation of the water, it will be H2O liquid. The reaction go forward and backward, giving to us hydronium ion or H positive plus OH negative, aqueous and aqueous. Since the water is a weak electrolyte, so the type of equilibrium in this case it will be ionic equilibrium. Simple and easy question. Okay, give reason 4. Water is neutral on litmus. The question, it will be the answer since the number of hydrogen ions which are responsible for the acidity equal to the number of hydroxyl ions. Okay, ionic product of water, product of water Kw. Kw is equal the concentration of the hydrogen ion multiply the concentration of the hydroxyl ion 10 power negative 7 multiply 10 power negative 7 equal 10 power negative 14. It is a constant number. Write the scientific term. Slide number 11. The multiplication of hydrogen ion concentration and hydroxyl ion concentration. Ionic product of water or Kw. Kw. Okay, now we are going to talk about the pH or the concentration of the hydrogen ion in the aqueous solutions. As in the preparatory stage, we said that the pH may be less than 7, may be equal 7, may be greater than 7. If the pH less than 7, it will be acidic, equal 7 neutral, more than 7 will be basic. Now we are going to talk about the pH. Then in the next video, inshallah, we are going to make a notes on the problems for Ostwald law and how to deal with it. Okay. Write the scientific term. The way to express the acidity or basicity of the substance in aqueous solution. It is the pH or is called the way to express the acidity or the basicity of the substance, the pH value. Maybe negative, the negative logarithm of hydronium ion concentration, it's else the pH. Rules: pH equal negative log hydronium ion concentration else negative log hydrogen ion concentration. BOH negative log hydroxyl ion. The value of the pH plus pOH giving to us 14. Okay, I'm thinking at the end today for this video. Inshallah, next video we are going to talk about the problems. It's a very important video for the problems for applications on Ostwald law and how to deal with it. See you soon inshallah next time. Assalamu alaikum wa rahmatullahi wa barakatuh.